Well, good day everyone. Welcome to Practical Guide Junior to GIS Expert Training Series, and this is part 2 of module number 3. And today's coverage is on the spatial interpolation, particularly the IDW or inverse distance weight. So spatial interpolation is nothing but a process of using point with known values to estimate values at other points. Like we have unknown values from known points, and we want to calculate or we want to estimate or establish values at other points within our location of interest. So as today's focus is in IDW, so I'll also try to define what IDW is actually as a means of interpolation or spatial interpolation. IDW enforces that the points which are near will have influence to this to unsampled locations. Like if we have a point A and we wanna compute for point B, which is nearer to point A, it means and we have a point C which is far from point B, the one we want to estimate. It means point A will have higher influence to point B, and point C will have little influence to point B, which is the unknown point, and A and C are locations with known values. So that is what IDW is trying to estimate. So again, since our training has been based in real world practicals and real world project, and so for this part we'll try to look at how we can try to map air pollution parameters, and actually we'll have data from the India Board of Pollution Control, and so we'll have data and we'll see how we can use those type of data to perform interpolation. This is an example of how air quality parameters from the Central Pollution Control Board of India is presented in Excel format. So these data have been collected from the board site, and as you can see, we have data from different months but have been collected on a daily basis. As you can see, it's an average period of 24 hours, and we have these parameters that have been collected from this site. And actually this Excel is of a station called Katihali in Hassan, as you can see, and the city is in Hassan and state is in Karnataka. So we'll try to see how these pollution control stations have been collected these data, and we can use these sample data from the stations to compute or to perform interpolation and estimate values of unknown location, which are particularly those locations with no air pollution control stations. So that's our project, and let's go to our QGIS software and try to add data. So this is our QGIS user interface again, and let's try to perform interpolation. So we'll need to have point feature data, which are the location of our control of our pollution control stations. So let's try to add the stations. These are point feature data, so we open them using vector icon, and these are air quality control stations. So let's try to add them and see. Now these are our points. So these are actually the stations. We can even try to name them and see their names, or we can check within the attribute information, and you see like we have their names and also the ID column. If we try to look at the attribute table, we don't see any air quality parameters. So it means we'll have location of our stations, and again we'll have an Excel file which we will try to rearrange or to manage our data, trying to filter data that are not relevant with our project and remain with the data that is cleaned and ready to be joined to these attribute information using the ID column. So before that, let's try to add also the administrative boundary of our area of interest, which is the Mangalore and nearby. shapefile, Mangalore and nearby shapefile. Let me try to expand this one. Okay, so it's Mangalore and nearby shapefile. As you can see, this one, and nearby Mangalore and nearby. So let's try to add Mangalore and nearby stations. Now we can take the administrative boundary down and we can realize and see our air quality control stations. And so let's try to name these by going to properties and labels. We choose single label again, and we can choose to have also a buffer, and we can choose the size of our text that we want. Then we place OK, and now these are the names. As you can see, these are the name of our stations. Air quality parameters, we need to now add the CSV or comma delimited text file containing the air quality parameters. So let's add the air quality parameters. I have tried to perform data filtering and I have named it as station CSV. Now let's try to open, and these are our air quality parameters, as you can see. So let's try to click on add and close. Now we have our station CSV. If we try to open the attributes, we'll see that we have a column with the name ID. So we'll use this ID column to join station attribute informations containing air quality parameters and their actual station location, which is the point feature layer. So to perform that, let's highlight the air quality stations layer. Then we double click it, or we right click and go to properties, where we'll have an option to join our layer. So here is an icon to join, and we have to click on the add on the plus icon so that we initiate a new join. And our join layer actually is the CSV, the station CSV. We want to join it with the air quality stations. So we choose the CSV and we join using the ID column, because the ID column is a unique identifier. Number one ID within the station CSV present the same information within air quality station layer. So that's the reason we choose ID. And here the target is also an ID, because it is the layer that is having the same unique identifier with the two layers. And after that we click on OK. Now we see that join layer station CSV has been performed, and we can click on apply, then OK. After having our joined layer, we can try to open now the attribute of air quality station and see the changes after performing data joining. Now you can see that we have used the column ID and we have joined the spatial and attribute information of our area of interest. The spatial information were within the point feature layer, while the attribute information were within the station CSV. But all these two data had an ID column presenting information, like number one within CSV stations presented Chikamagoru, and at the same time number one ID presented the Chikamagoru station within the point feature layer. So that's how we perform data joining. Now let's go again back to our interpolation, and again our input layer is air quality station, and now we have to choose interpolation attribute. The interpolation attribute now, it is the information of our air quality parameters, the one that we want. Let's go for carbon monoxide and try to click on add. Then we can now choose to play around the output raster size, which is actually the spatial resolution of our output. Now let's try to leave everything as the way they are, but also we can choose to minimize it so that we have we can choose to have 0.01 pixel size, and we can click on run. Well, we see there is a wrong missing parameters, which is the extent. We need also to establish the extent of our analysis, which is this. Actually, let's go with, we calculate the extent from the air quality stations, and then we can choose on run, and we can close now. And this is our output, as you can see. Again, because our area of interest is in Mangalore, so you see, if we try to play around with the properties of our output, for instance, let's choose single band pseudo color and classify, and let's choose the invert color ramp, so that higher values of carbon monoxide concentration will be presented with red color, and the lowest values of concentration of carbon monoxide will be presented with a blue color. So let's choose apply and OK, and now this is how our output is. And because our area of interest is in Mangalore, we can try now to filter this layer to the extent of Mangalore. We can go to filter and try to choose, I think it's dname. Dname is equal to Mangalore, and we can choose OK. Now let's try to take this layer up here. Yes. So this is Mangalore district. Now what we have to do is we can run extraction, and this is actually its extraction by mask. So let's go to raster. Within our interpolated output, let's go to raster. Then we choose extraction and extract by mask layer. Our input information is interpolated output, and our masking layer is now the Mangalore nearby layer, and we can run our mask. So you see now our results are here. We can try to uncheck this interpolation, and we can also uncheck this one, and now we remain with our area of interest, which is the Mangalore. So let's try to change the style of our output again by going to single band pseudo color and classify, then choose the invert color ramp, and again choose on apply and OK. So here is again our output, as you can see, and we can choose to remove this one, and we can see like, okay, this is the Mangalore area, and this is the concentration or distribution of carbon monoxide concentration within our area of interest. So we had a single air quality control station within Mangalore, and if you can observe, the color of our location of our station is almost near to zero, meaning that the concentration is very low. But again, as you move toward the north, you can see that we have used these Udupi stations, which recorded higher values of, if we check this, we see like Udupi recorded higher value of concentration of carbon monoxide, but we used these Udupi to estimate values near to this location. So as we said within IDW, that it enforces that the nearby location have influence to the point which we try to estimate as compared to those far distant points of known values. So you see Udupi is having higher concentration of carbon monoxide, and because this area is near to Udupi, it also have higher concentration of ozone. But because Mangalore is far from this point, Mangalore is having within the Mangalore there is less concentration of carbon monoxide. And again, this part is near to Mangalore, and you can see that the distribution again tells that concentration is in intermediate levels as compared to these areas with higher concentration of carbon monoxide. So that's how you map air quality parameters, or that's how you provide an estimation of pollution concentration within an area of your interest. So thanks for watching, and see you in the next video.